What's up, guys? So we're going to do one more video here, and I'm going to combine the last two homeworks into one video because now that we've talked about population proportion, SEP, and how that leads to the confidence interval, it makes it a lot easier to talk about the other half. So the other half being mean, okay? So all that stuff we talked about before was based on p hat. It was based on this idea of a percentage from a population, a proportion from a population. So going back to like drawing marbles out of a bag, what percentage of the marbles are red? What percent of the class passed the test? These percentages from a population is p hat. That's a statistic describing a population. Another statistic you can use to describe a population is mean. Okay, so instead of talking about what percentage are green or what percentage passed the test, we might talk about what was the average height of the boys on the basketball team? What was the average score on a test? When you talk about the average, that's mean. Instead of talking about proportion, we're talking about a mean. Well, we can do all the same stuff that we did with a proportion, we can do it with a mean, okay? So let's just look at this. So standard error of the mean, SEM, it's very similar to SEP. It's the same concept. It's the standard deviation of the distribution of the sample means. So if I take a sample, so let's say I'm talking about the heights of boys at Hiram High School. If I take a sample and I come up with 5'9", I do it again and I get 5'7". I do it again and I get 5'8". I get lots of different samples, get the average, and I get a different average each time. Well, those averages should form, going back to our normal distribution, a curve like this, right? And in the center of that curve should be the actual population mean, the actual average. If I take enough samples, then the center of that curve is going to be the actual average height of the boys at Hiram High School. Even if I don't measure every single boy, it's going to be so close to the population mean that it's going to essentially be accurate. So same concept as what we did with p hat. The only difference is how we calculate it because the numbers work a little differently. So instead of SEP, we have SEM, the standard error of the mean. And it's simply S, which is the sample standard deviation. Okay, that's S. Divided by the square root of the number of samples, the size of the samples. Okay, so here's an example. A sample of 30 test scores. Again, assuming this is out of some larger set of test scores. A sample of 30 test scores had an average score of 72.5 with a standard deviation of 3.2. The only thing we actually need in this problem, at least for now, to find the SEM is we need the standard deviation and N, but there's three numbers here. Well, the standard deviation is 3.2, so that goes here. The sample is 30. We had 30 tests in our sample, so that goes here. If I put this in my calculator, I get an SEM of 0.58. In other words, I can actually draw this normal distribution. Our sample mean was 372.5 with a standard deviation of 0.58. So if I add 0.58 here, that'd be something about like 73 point something. And if I subtract 0.58 here, it'd be somewhere around, it'd be close to 72, a little less than 72. But you see, if I add this number and subtract that number, this is the standard deviation. So remember, the SEM is the standard deviation approximately of if I were to take lots and lots of test score samples, okay? Now, I can go ahead and talk about the confidence interval and the margin of error and all that kind of stuff because it's really the same thing. We use a slightly different formula to get it, but it's the same exact concept. I don't need a 20-minute video to talk about that with mean now that we've gone through and talked about it with proportion, okay? So extending this question, find a 95% confidence interval for the population mean score in the situation above. Instead of looking for the population proportion, I'm looking for the population mean, okay? The formula, I wrote it out here. It's the sample mean that we found. Instead of taking p hat and adding, subtracting something, I'm taking the mean and adding and subtracting something. Still multiplying by the critical value because remember, this is still the standard deviation of the sample distribution. If I were to take a bunch of samples and get a normal distribution, this would be how many standard deviations I've got to go left and right for that certain confidence interval that I want. And this is the standard deviation of the normal of the sample distribution. It's SEM. So I'm going to add or subtract this, just like I did with p hat, okay? So the mean is 72.5, that's in the original problem, plus or minus 95% confidence interval, means I got to look at that table from before. Let me find it here, 95%, I want 95% confidence, I need 1.96 for my critical value. So you're going to use that table a lot when you're doing this. 1.96 times, and this is just what I found before, the SEM, okay? That's all this is, 0.58. So I put this in my calculator. I subtracted first, I got 71.36. Then I added, and I got 74.46. Okay. So what I'm saying here is I'm 95% confident that the actual mean of all the test scores, not just these 30, but the actual mean of all the test scores is somewhere between 71.36 and 74.46. 95% confident. That means there's a 95% probability that I'm correct in saying it's between these numbers. Okay, there's only a 5% chance that the actual population mean is outside of these two numbers.